Hello everyone, Mrs. Lindsay Pereira here. Today we're continuing on an extension of slope. Now we're going to actually graph lines, which we started to get into a little bit. Let's first start with this equation, 2y minus 6x equals 4. We're going to fill in a table of values. This is one way you can always graph any type of equation, by starting off making a t-table. We are going to typically start with values with 0, and then I'm going to put some positive numbers and some negative numbers, and I'm going to put some, again, I usually start with this, especially when I'm graphing linear equations. There are some reasons I would choose different numbers, but this way we get see where the graph is in all quadrants. If we pick, again, our origin and then points that are positive somewhere over here in either the first or fourth quadrant, and then over here somewhere in the second and third quadrants. And all I'm simply going to do is plug in these values for x. And there's a couple different ways to kind of think about it. We're going to do this problem in two different ways. If I plug it in, 2y minus 6 as is with the equation. This is what we call standard, almost standard form. It's pretty close. I would just switch the x and the y. So it would be ax plus by equals c. So if we just flip-flop this, it'd be negative 6x plus 2y equals 4. That's standard form. Sometimes standard form, they have it equal to 0, so the 4 would be on the other side. And we're not going to get into that too much right now. We're just going to plug it in as is and solve. So I'll have 2y plus 18 equals 4. Subtract 18. So negative 14. So now we get that to be negative 7. And we can go ahead and plot it, or we can figure out our entire chart first, however you'd like to do that. 1, 2, 3, 3, 4, 5, 6. And that goes down here. Now we plug in negative 2, and again, make sure you're plugging it in for your x's here, not your y's, even though the y is the first one there. So 2y minus 6 times negative 2 equals 4, and I'm going to go through, oops, that should be a positive, 12. This entire process again, subtract over 12, so that'll be minus 8. So that'll be negative 4, and I'll go ahead and plot that. Negative 1. So this is going to be 2y plus 6 equals 4. Subtract over. So then that will give me also negative 1. 0 makes life a little bit easier because this term here, the 6x, just becomes 0. So it's really just simply 2y equals 4. So then that would make this 2. And you can kind of start seeing the trend here. So sometimes you can do this without even filling the rest of this. Hopefully you see that the slope here is going to be up 3 to the right. So that'd be positive 3 to the right 1. So I could continue 1, 2, 3 to the right 1, and then keep going from there. And notice it's going to start going off the graph. So if I plug these in, that one, we get that to be 5. And again, you keep counting 2, 3, and it goes off the chart a little bit. So this would be 8 and this would be 11. But again, you can always verify that. I'll just plug in the 3 here. So now this is negative 18. So when I add that over, that's why we get that larger number there. So it'd be 11. Okay, so again, now I'm going to graph it. Line here. I'm going to adjust it slightly, again using a straight edge. It's helpful there at the side of your calculator, that type of thing. I'm doing this because it definitely makes the line straighter versus me drawing it. Okay, like I said, we're going to do this problem in two different ways. Exact same problem at the bottom of the page here, but we're going to put it in slope-intercept form. So in other words, solve for y. Y is all by itself over here on this left-hand side. So if I add over a 6x, and again, that's not a like term with 4, so I literally just have to write 6x plus 4 then I divide everything by 2. Okay, so now I don't have to do a table. I can look at my starting point here, which is going to be my y-intercept, which is order pair 0, 2. So I go up here and plot my point. Then I look at slope, and I count out slope. That is 3 over 1. So again, remember that's going to mean up 3, because the numerator is my rise. Then over 1. Now everybody says over, but please make sure you realize because it's positive, it goes to the right. If that's negative, it's to the left. So we count up 3, to the right 1. And notice I'm already running off my graph. So the exact opposite of this, I could also say I have a slope of negative 3 over negative 1. So the opposite would be down 3 to the left 1. These are the exact same slopes. So I can go down 3 to the left 1. Down 3 to the left 1. And I always say, fill up your chart. Okay? So don't just put 2 points on there and draw a line. Fill up your graph. Okay? Make sure that it goes off the graph so you can see the shape of the graph and where it extends in the various quadrants. Okay? All right, so let's go to the next page. A couple things here in terms of graphing. Notice the directions here say use any method. So you could make a table, you could solve it for y, whatever you would like to do. I would suggest as you're doing these for your homework that you choose a variety of them. Don't do them all the same way. Do some of them solving for y, do some of them making a table. Okay, I want to tackle C here though, because it's a special case. This means if I make a table, no matter what my x's are, every single time, all my y's are negative 2. No matter what these are. I could put any number in here. Okay? So where y is negative 2 is here. This is where x is negative 2. We don't want x. We want on the y-axis here, right there. Okay. So is this going to be vertical or horizontal? And hopefully you realize it is going to be horizontal. Because again, every single one of these order pairs here is when y is equivalent to negative 2. Another way to think about that problem is if I put in slope, my slope is 0. Because it's not there. So the only way for slope to not be there, that x value not to be there, is when I have slope of 0. So I'm not counting my rise up at all. Okay, so when you have your special cases, your vertical, your horizontal, it's difficult to make a table. It's difficult to put it in slope-intercept form. It's kind of more of a thinking problem. But again, remember this means every single y is negative 2. So all of my y values, put that mark there, all of my y values have to be negative 2, and that's where this occurs all along that green line. Okay. All right, so now I'm going to leave those for you guys to do for homework. We're going to go over to interpreting slope from a graph. Okay, so let's take a look here at problems 10 and 11. Okay, so reading the directions here, it says answer the questions for each graph. Be sure to include a unit of measurement with each answer. Okay, so we're going to talk about 10 and 11. So here's our graph. So on the x-axis is time in months. On the y-axis is savings in terms of dollars. So it's talking about money saved. How much money had been saved at time 0? Well, time 0 is here, which would give me this order pair. So that would give me $100 saved. Okay. So 11 says, what was the rate? So when you see that word rate, hopefully you're thinking slope. Okay. So what was the rate of savings? So money per month. Okay. Couple different ways to kind of think about this. We can actually do our slope formula, which is, again, subtract your y's over your x's. So we can literally pick a couple ordered pairs. There's 3 of them here. Plug that in. You can also literally look at your graphs and think about rise over run, which is the method I'm going to go ahead and choose to do. So if I go from this point, again, I always go from left to right. Just feel like that's a little bit easier route to go. I went up 100. Now make sure you're looking at the scale here. Up 100. So I went up 100 because it goes 100 to 200. And then I go 2, 4. So again, look at your scales. This is counting by 2. So this is 100 over 4. Again, both of those positive went up and went to the right. So that's going to be $25 per month. Okay, so again, please make sure you're labeling these. Let's go down to 16 and 17. Okay, same idea here. This is elevation and temperature. On the x-axis is your elevation times 1,000 feet. That's an important little notation. And our temperature is our y-axis here. That's in terms of degrees Fahrenheit. So 16, what was the temperature at sea level? Okay, well, sea level, hopefully you know that is going to be 0 feet here. Okay, so 0 feet. So when it's at 0 feet, what is my temperature? Well, my ordered pair is not here. My ordered pair is actually up here. So that temperature is going to be 40 degrees. All right, what about at 20,000 feet? Now remember the elevation is measured in thousands of feet. So that would, the 20,000 would correspond to 20. So that's actually 20,000 here. So here's my ordered pair for that. What's my temperature there? That's at negative 20 degrees Fahrenheit. Okay. 17. At what rate did the temperature change? Again, rate. Ding, 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 ding. Slope. We're thinking slope here when we see that word. Did the temperature change? So degrees Fahrenheit per 1,000 feet. So in this case, again, I can literally just count if I would like. So here's one ordered pair. And then I'm going to count over to my next ordered pair. So I'm going left to right. So now I'm going down. So I go down 20, and then that's a 10 right there. So 10, 20, 30. So I go down negative 30, and then I go over 5, 10, positive 10. All right, so then we reduce that to negative 3 degrees per 1,000 feet. Sorry, I got to angle this just a little bit. Not a lot of room over here. It might be a little easier for you guys to actually write your answers below. You have a lot of space there. So I'll do that for 18 and 19, write that below. All right, so let's take a look at 18. We'll continue on here with the same problem. At about what elevation was the temperature at 0 degrees? So what was the elevation at a temperature of 0 degrees? So now we're looking at 0 degrees Fahrenheit. So Fahrenheit is our temperature, which is our Y value. Where do we have 0 degrees for our Y value? Okay, and that is going to occur at this point right here. Okay, so that's going to give us, I'm going to approximate that to be 14. So again, remember it's in thousands of feet, so that's 14,000 feet. Okay, so let's take a look at number 19. What would the temperature be outside a jet flying at 40,000 feet? Okay, so notice that is off our chart here. It only goes up to 25, and actually we don't even have a point at that. We have a point, our last point is right here. So going off of our graph, we have to think about our equation. Y equals mx plus b is probably the easiest way to think about this. Well, we already found m in 17, which is negative 3. That looks like, hopefully you realize that's a degree mark there. So that's negative 3x. And then what is b? Well, b is our y-intercept, and our y-intercept is 40. Now let's go back and read the equation. The question, what would the temperature be outside a jet flying at 40,000 feet? Well, again, elevation is in terms of thousands of feet, so we really want to know, when is x 40, what is y? Okay, so plugging that in, y equals -3, x is 40, plus 40, solving that, negative 120 plus 40, that gives us to negative 80 degrees. Okay. All right, so now this is out of our packet, but there's also a worksheet on this day, which says graphing linear equations, just a single sheet of paper. So if you have not printed that yet or have not taken a look at it, you can do one of two things: pause the video, go print it, or grab a notebook and then you can write some of these down. We're going to do a couple of these examples, but for your homework is going to be finish the packet as well as finish this graphing linear equations here. Okay, so let's do a couple of these problems here. We're going to start off with number 1. When we graph number 1, y equals 2/3 x minus 6. Notice I didn't give you any directions here. You can graph it however you want. However, since it's in the form y equals mx plus b, in other words, slope-intercept form, I would probably choose to do that form. So b, or y-intercept, is -6. That is always the first thing you start with when you're graphing the y-intercept. It gives you a starting point to count slope from. You don't just automatically start at the origin. You got to start from the y-intercept. Now I'm going to count out a slope of +2 over +3. So rising 2 and to the right 3. And again, fill in your chart. Put as many points on there as you can get. And I'm going to run off the chart at that point in time. And then I'm going to draw my line. Okay. All right, so let's jump down to number 4. Directions here change slightly. It says write the equation for this line. Typically, we're going to do y equals mx plus b form, but to be honest with you, if you put it in standard form, that would be fine. This is probably a little bit easier form because you always just have to find m and b. So that's what I'm going to fill in. So b is my y-intercept, which is at 5. Now if I, excuse me, count out slope, I go up 1, and then I went to the right, 1, 2, 3. So that's going to be 1 over 3. Okay, and this concludes your notes for graphing equations of lines. So again, your homework is to not only do this single sheet of piece of paper, graphing linear equations, but also to finish the notes from topic 6, graphing lines.